Have you ever looked up at the night sky and wondered why everything is moving? Planets orbit stars. Stars cluster in galaxies. Even those galaxies are on the move. It's a cosmic dance, a never-ending ballet of celestial objects. But what is the music that drives this dance? Why is nothing in space ever truly still? The answer lies in a fascinating interplay of forces and phenomena. Gravity, momentum, and even space weather all play a part. Understanding these factors helps us unravel the mysteries of the universe. It's a story of cosmic connections and the powerful forces that shape our cosmos. So let's embark on a journey to explore the science behind this celestial motion. Let's uncover the secrets of why everything in space is constantly moving. Imagine a giant invisible hand guiding the stars and planets. That's gravity. This unseen force is what keeps the cosmos in a delicate balance, orchestrating the dance of celestial bodies across the universe. It's the most dominant force in the universe, influencing everything from the smallest particles to the largest galaxies. Gravity dictates how celestial objects interact, determining their paths and movements. It pulls them toward each other, creating the intricate cosmic ballet we observe. This pull is what makes an apple fall from a tree, a simple yet profound demonstration of gravity at work. And it's the same force that keeps the Earth orbiting the Sun, maintaining the stability of our solar system. Sir Isaac Newton first described gravity in the 17th century. He called it the law of universal gravitation, a groundbreaking concept that revolutionized our understanding of the universe. This law states that every object in the universe attracts every other object with a force that is proportional to their masses. The strength of this attraction depends on two things: the mass of the objects and the distance between them. The first is the mass of the objects. More massive objects exert a stronger gravitational pull. The second is the distance between them. Objects that are closer together experience a stronger gravitational attraction. More massive objects have a stronger pull, influencing the motion of other bodies around them. Objects closer together experience a stronger gravitational attraction, drawing them into each other's orbits. Albert Einstein later refined our understanding of gravity with his theory of general relativity, which provided a deeper insight into the nature of this force. Einstein's theory showed that gravity is not just a force acting at a distance. It's a curvature in the fabric of space-time itself, bending the very dimensions we exist in. Massive objects create a dip in space-time, like a bowling ball on a trampoline, causing other objects to move towards them. This curvature is what we experience as gravity, a fundamental force that shapes the universe. Now, imagine throwing a ball in space. Without gravity to pull it down or air resistance to slow it, the ball would just keep going. What happens? It keeps going, right? That's momentum in action. Momentum is what keeps objects moving unless something stops them. Momentum is the tendency of an object to keep moving in a straight line at a constant speed unless acted upon by a force. This is a fundamental principle of physics. In space, where there's almost no friction, objects can maintain their momentum for incredibly long periods. This is why satellites and space debris can travel vast distances. This momentum is a leftover from the Big Bang. The initial explosion sent everything flying outwards. The Big Bang was the event that created the universe. It was a massive explosion that set all matter into motion. It set everything in motion, and that motion continues to this day. The universe is still expanding. The initial expansion of the universe gave all matter its initial push. This push is what keeps galaxies, stars, and planets moving, and objects have been moving ever since. From the smallest particles to the largest galaxies, everything is in motion. Think about the Earth orbiting the Sun. It's a perfect example of momentum and gravity working together. Gravity pulls the Earth towards the Sun. This force is what keeps the Earth in its orbit. But the Earth's momentum keeps it from crashing into the Sun. Instead, it moves in a stable orbit. Instead, the Earth continuously falls towards the Sun, but also keeps moving forward. This forward motion is due to its momentum. This results in an orbit, a delicate balance between gravity and momentum. It's a beautiful dance that keeps our planet in just the right place. Section 4. Space weather, a stormy influence. Space may seem empty, but it's actually teeming with activity. Space weather refers to the changing conditions in space, particularly those driven by the sun. The sun constantly releases a stream of charged particles called the solar wind. This wind, along with solar flares and coronal mass ejections, can impact objects in space. Imagine the solar wind as a gust of wind pushing against a sailboat. This wind can influence the trajectory of satellites. It can even disrupt communication systems on Earth. Understanding and predicting space weather is crucial for protecting our technology in space. It's a field of ongoing research. Scientists are constantly trying to improve our ability to forecast these solar storms. Section 5. ISRO's Insights, Unraveling the Mysteries. India's space agency, ISRO, is playing a crucial role in advancing our understanding of space dynamics. ISRO's Aditya L1 mission is a prime example. This mission is dedicated to studying the sun. It's designed to observe the sun's atmosphere, its magnetic field, and the solar wind. The data gathered by Aditya L1 will help scientists understand the processes that drive space weather. This knowledge will improve our ability to predict and mitigate the impacts of solar storms on Earth and our technology in space. ISRO has also developed sophisticated software like Pravaha. This software simulates the flow of air around objects like rockets and satellites. This is crucial for designing spacecraft that can withstand the forces of launch and re-entry. Section 6. A connected cosmos, the ripple effect. The motion of objects in space is not isolated. Every celestial body, from the smallest asteroid to the largest galaxy, is part of a grand cosmic dance. It's interconnected in fascinating ways. The gravitational forces between these objects create a complex web of interactions that shape the universe. The gravitational pull of one planet can subtly influence the orbit of another. This delicate balance ensures the stability of planetary systems. The death of a star in a supernova explosion can send shockwaves through space. These shockwaves travel vast distances, carrying energy and matter. These shockwaves can trigger the formation of new stars. In the aftermath of a supernova, the remnants can collapse under gravity to form new stellar nurseries. Einstein's theory of general relativity predicted the existence of gravitational waves. These waves are ripples in the fabric of space-time itself. These waves are ripples in space-time caused by the acceleration of massive objects. When massive bodies like black holes or neutron stars accelerate, they disturb space-time. Imagine tossing a stone in a pond. The ripples spread outward from the point of impact, creating waves that travel across the water's surface. The ripples spread outward from the point of impact. Gravitational waves are similar. They propagate through space-time, carrying information about their origins. They carry energy away from massive events like black hole collisions. These cataclysmic events release enormous amounts of energy, detectable across the cosmos. The detection of gravitational waves has opened a new window into the universe. Instruments like LIGO have allowed us to observe these waves directly. It allows us to study some of the most energetic events in the cosmos. By analyzing these waves, we gain insights into the fundamental nature of the universe. Section 7. The Neverending Journey. The universe is a place of constant motion, a cosmic dance driven by forces that have been at play for billions of years. From the smallest particles to the largest galaxies, everything is moving, evolving, and interacting. As we delve deeper into the mysteries of space dynamics, we gain a greater appreciation for the elegance and complexity of the universe. We begin to understand our place within this vast and dynamic cosmos, and we are left with a sense of wonder and awe at the beauty of the celestial ballet that unfolds above us every night. The journey of discovery is never-ending. As we continue to explore, we are sure to uncover even more secrets of the universe and the forces that keep it in motion.